Hey everyone, and welcome back to TalkTensors, the show that takes dense, jargon-filled academic papers and, distills them into something you can actually digest.
Yeah.
Today we're tackling a fascinating paper called Solar, Scalable Optimization of Large-Scale Architecture for Reasoning.
Okay.
It caught our eye because it dives into a crucial question: how can we make AI think more effectively?
Right. And the paper makes a really interesting argument. It points out that current large language models, or LLMs, are kind of limited because they primarily think in a linear way, like a chain of thought. But the human brain doesn't work like that.
No, not at all.
We jump around, connect ideas in different ways, use hierarchies and relationships.
Exactly. So the Solar paper proposes that if we want AI to truly excel at complex problem solving, we need to teach it to think more like us using structures like trees and graphs, not just chains.
Yeah, and what's really cool is that the authors actually found that using the right thinking structure for a particular problem can dramatically improve the AI's accuracy.
Really?
Yeah, it's pretty remarkable. Wow.
And they didn't just stop at the theory either. They actually built a system called TagShort for topological annotation generation to automatically create and label data sets for these different reasoning structures. This is a big deal because it makes AI research much more efficient.
Right. I can imagine trying to manually label thousands of data points for complex reasoning patterns would just be...
Oh, it would take forever.
Yeah.
Absolutely.
So TAG is like this super-powered labeling machine that streamlines the research process. But there's another key innovation here, right? The topology competition. Tell me more about that.
Well, the topology competition is where things get really interesting. Instead of pre-selecting a reasoning structure, Solar lets different structures like chains, trees, and graphs compete against each other to find the best solution to a given problem.
So it's like an AI battle royale where the fittest reasoning structure survives.
In a way, yes, but the fitness is determined by how well each structure solves the problem at hand.
This dynamic approach allows the AI to be more flexible and adaptable, just like humans are.
That makes sense. This all sounds very impressive. But before we get too deep into the weeds, can you give us a little context? How does Solar fit into the history of AI reasoning? Were there any precursors to this idea?
Absolutely. Solar didn't just emerge out of a vacuum. You can trace its lineage back to earlier methods like chain of thought, COT, tree of thought, 2T, and graph of thought, GoTT. Each of these built upon the last, adding complexity and flexibility to AI's reasoning abilities.
So Solar is kind of like the culmination of these previous efforts. It takes the best elements of each and integrates them into a single unified framework.
Exactly, and that's what makes it so exciting. It's not just an incremental improvement, it's a potential paradigm shift in how we approach AI reasoning.
Okay, you've definitely piqued my curiosity. Now I'm dying to hear about the novel notions, those out there ideas that Solar has sparked. Hit me.
All right, buckle up. Let's step into the realm of speculation where we explore the potential impact of Solar on the future of AI. One thought that popped into my mind while reading this was, could Solar be used to create AI systems capable of making real-time strategic decisions in incredibly complex and dynamic environments?
Ooh, that's interesting. Give me an example.
Imagine financial markets where things are constantly changing. An AI powered by Solar, capable of shifting its reasoning structure on the fly, could analyze massive amounts of data, predict trends, and execute trades with a speed and accuracy that no human trader could match.
That's a powerful image, but it also raises some concerns. I mean, giving an AI that much control over financial markets, what if something goes wrong?
You're right to be cautious. Any technology this powerful needs to be developed and deployed responsibly. We'd need robust ethical frameworks, rigorous testing, and probably some kind of kill switch, just in case.
Yep, just in case.
But if we can get it right, the potential benefits are enormous. Imagine an AI that can stabilize markets, prevent crashes, and ensure fairer trading practices.
Right, that would be incredible.
It would be transformative.
Okay, so financial markets are one potential application. What other wild scenarios could Solar revolutionize?
How about something a little more intense? Imagine a military scenario where an AI is tasked with coordinating troop movements, managing logistics, and making strategic decisions in the heat of battle.
Whoa, we're talking about AI generals now. That sounds like something straight out of a science fiction movie.
Perhaps not as far-fetched as it sounds. An AI powered by Solar could analyze battlefield data, predict enemy movements, and adapt its strategies in real time, potentially giving its side a decisive advantage.
But again, the ethical implications are huge. Are we comfortable handing over life or death decisions to machines, even if they are super intelligent?
That's a debate we need to have as a society, and it's one that's only going to become more urgent as AI continues to advance.
Definitely a topic for another deep dive, maybe.
Maybe so.
Okay, those are some pretty mind-blowing applications, but I have a feeling you've saved the most radical novel notion for last, haven't you?
You know me too well. Remember our earlier discussion about combining solar with curriculum learning? Let's take that to its logical extreme.
I'm all ears.
What if we could create an AI that starts with the reasoning abilities of a toddler, then gradually learns and develops just like a human child? We could expose it to increasingly complex information, challenge it with progressively harder problems, and watch as its reasoning abilities evolve over time.
So instead of trying to program intelligence from the top down, we're essentially growing intelligence from the ground up.
Precisely. And if we combine this approach with Solar's dynamic reasoning structures, we might just end up with an AI that can think as flexibly and creatively as a human being.
That's both exhilarating and terrifying. At the same time, we'd be creating a whole new form of intelligence, something that could potentially surpass our own.
Of course, this is all highly speculative. We're talking about pushing the boundaries of what's currently possible. But who knows, maybe one day these novel notions will become reality.
And that's what makes AI research so fascinating. It's a journey into the unknown, full of possibilities, challenges, and, well, let's just say it's a journey worth taking.
Absolutely. And who better to navigate that journey than us, the intrepid explorers of the AI frontier?
All right, and that wraps up part 1 of our deep dive into the solar paper. Join us in part 2, where we'll unpack the paper's methodology and findings in more detail.
Sounds good. Welcome back to TalkTensors. We just left off discussing solar's potential to revolutionize everything from finance to, well, the future of intelligence itself.
Yeah, we did get a bit ahead of ourselves there.
It's easy to do when you think about all the possibilities.
It really is. So let's reel it back in for a moment and dig into the nuts and bolts of what the researchers actually discovered.
Okay, sounds good.
What specific insights did they uncover in their experiments?
Well, they started by testing these different reasoning structures, chains, trees, and graphs on a couple of established mathematical reasoning datasets. Math and GSM-8K, and they wanted to see which structure performed best and whether there was a clear winner across the board.
So was there? Like, did one reasoning structure come out on top, or were the results more nuanced than that?
Definitely more nuanced, which is actually one of the key takeaways from the paper.
Okay.
They found that there's no one-size-fits-all solution when it comes to AI reasoning.
Makes sense.
Different problems actually benefit from different thinking structures. Sometimes a simple chain of thought is enough. Other times you need the branching logic of a tree, and sometimes you need the interconnected complexity of a graph.
That makes a lot of sense when you think about it. Even as humans, we don't approach every problem with the same thinking style. Sometimes we think linearly, sometimes we brainstorm with branching ideas, and sometimes we need to see the connections between different concepts.
Exactly. And the solar paper highlights this adaptability as a crucial element of intelligence, whether it's human or artificial.
I like that.
The researchers actually introduced a clever metric called win rate to measure how often a particular reasoning structure leads to the correct answer.
Interesting.
Compared to others. And what they found is that the win rate varied significantly depending on the problem they were tackling.
Okay, so they've shown that different problems call for different reasoning structures, and that the solar approach is flexible enough to handle this. That's an important finding in itself.
Right.
But how does solar actually choose the right thinking structure for the task?
Yeah.
It can't just be random, right?
You're right. It's not random at all. This is where the topology competition that we talked about earlier comes into play.
Right, the AI battle royale.
Exactly. Remember how I described different reasoning structures competing against each other to find the best solution?
Yeah, it kind of reminded me of a reality TV show where different algorithms are duking it out for the grand prize.
Yeah. Well, maybe not quite as dramatic as that, but the basic idea is that solar doesn't pre-select a reasoning structure. It lets different structures try to solve the problem, then uses a sophisticated reward system to choose the one that performs the best.
So it's like the AI is running its own internal tournament to see which reasoning structure is most effective for the challenge at hand.
That's a great way to put it. And this dynamic competitive approach allows solar to be much more adaptable and effective at problem solving than traditional LLMs, which are often stuck with one way of thinking.
Now, I remember you mentioned earlier that solar can achieve better results with less computational power.
Yes.
Can you elaborate on that a bit? That seems like a huge advantage, especially as AI models continue to grow in size and complexity?
Absolutely. One of the key findings of the paper is that using the right thinking structure can significantly reduce the computational cost of solving a problem.
Interesting.
If you think about it, a simple chain of thought might be sufficient for a straightforward task, while a more complex problem might require the interconnected reasoning of a graph by selecting the most efficient structure for the job. Solar avoids unnecessary computation and improves overall efficiency.
So it's not just about making AI smarter, it's also about making it leaner and more efficient.
Exactly.
That's really impressive. But
Yeah.
I'm curious, how does Solar compare to other approaches in the field? Is this a major breakthrough or an incremental improvement?
I'd say it's more than just an incremental improvement. Remember those earlier methods we talked about, chain of thought, tree of thought, and graph of thought? Well, Solar doesn't just build upon them.
Yeah.
It unifies them. It takes the best elements of each approach and combines them into a single coherent framework.
So it's like taking the best features from different cars and creating a supercar.
Right.
It's not just about adding a spoiler or a new engine, it's about redesigning the entire vehicle from the ground up.
That's a great analogy. Solar isn't just about inventing a new reasoning structure. It's about creating a system that can leverage the strengths of all existing structures. And that's a potential game changer.
Okay, you've convinced me that Solar is innovative and potentially groundbreaking. But let's shift gears for a moment and talk about practicality. Can we actually use these ideas to build real-world AI systems? Or is this still purely theoretical?
That's the million-dollar question, isn't it? And the answer, like most things in cutting-edge research, is that it's complicated. The authors have demonstrated that Solar works in a research setting.
Sure.
But there are still a lot of challenges to overcome before we see it powering everyday applications.
Like, what kind of challenges are we talking about?
Well, one of the biggest hurdles is scaling up the system to handle the complexity and messiness of real-world data. The data sets they use in the paper are relatively small and well-defined.
Right.
But the real world is full of noise ambiguity and unpredictable events. It's like training an AI to play chess in a controlled environment, then dropping it into a real-world game with distractions, time pressure, and psychological warfare.
So it's not just about the algorithms themselves, it's also about making sure the AI can function effectively in a chaotic and unpredictable environment.
Yeah, exactly. And there's also the issue of computational cost. Even though Solar is more efficient than traditional LLMs, it still requires significant processing power, especially for complex tasks. This means we need to continue developing hardware and software that can keep up with the demands of these advanced AI systems.
You bring up a good point. As AI models become more sophisticated, they also become more resource intensive. So it's a constant race to improve both the algorithms and the underlying technology that supports them.
Right. And we can't forget about the ethical considerations.
Of course.
We've already touched on this a bit, but it's worth emphasizing that any technology as powerful as AI needs to be developed and deployed responsibly. We need to think carefully about the potential consequences, both positive and negative, and ensure that these systems align with our values and goals as a society.
That's an incredibly important point. It's not enough to just focus on the technical capabilities of AI. We need to have a broader conversation about how these systems will impact our lives, our work, and our future as a species.
Absolutely. It's a conversation that needs to involve everyone, not just scientists and engineers.
Okay, so we've covered a lot of ground here, from the specific findings of the Solar paper to its broader implications for the future of AI. What are your final thoughts on this research? What excites you the most about it?
What excites me the most is the potential of Solar to make AI more flexible, adaptable, and efficient. I think this research represents a major step forward in our understanding of how to create intelligent systems that can truly learn and reason like humans. And while there are certainly challenges ahead, I'm optimistic that Solar and other similar approaches will pave the way for a future where AI can help us solve some of the world's most complex problems.
I share your optimism, and I think it's crucial to have these conversations now so we can shape the development of AI in a way that benefits everyone.
And speaking of shaping the future, remember those novel notions we discussed earlier, those out there ideas inspired by the Solar paper? Well, in our next segment, we're going to revisit those ideas and explore how they might lead to even more groundbreaking advancements in AI. So stick around because things are about to get really interesting.
Welcome back to TalkTensors. So we just finished diving into all the technical details of the Solar paper, but now it's time for everyone's favorite segment, novel notions.
Yeah, that's right. It's time to let our imaginations run wild and explore some out there ideas that, this research has sparked.
I heard it.
Remember, these are thought experiments,
Right.
not concrete predictions. We're just having some fun and seeing where these ideas might lead.
I like it.
All right, so let's revisit that idea of solar-powered AI making real-time strategic decisions in those complex, dynamic environments.
Okay.
Remember, the paper focuses on mathematical reasoning, but what if we push that concept further?
I'm intrigued. Give me a specific example.
Okay, imagine a financial market AI that can analyze mountains of data, predict trends, and execute trades in milliseconds. And it's doing all of this while constantly adapting its reasoning strategy based on the ever-changing market conditions.
So instead of relying on pre-programmed algorithms, this AI would be able to think on its feet and make decisions that no human trader could even fathom.
Exactly. It could spot patterns that are invisible to us, react to news events in real time, and maybe even anticipate market shifts before they happen. It's like giving an AI the intuition and flexibility of a seasoned trader, but with the processing power and speed of a supercomputer.
That sounds incredibly powerful, but also a little terrifying, right? I mean, giving an AI that much control over financial markets, what safeguards would we need to put in place to prevent it from going rogue and crashing the entire system?
That's a really critical question, and one that would need to be addressed very carefully. We need incredibly robust ethical frameworks, rigorous testing procedures, and probably some kind of kill switch just in case things went haywire.
Yeah, kill switch, always a good idea.
Right, but if we could get it right, the potential benefits are enormous. Imagine an AI that could help stabilize markets, prevent crashes, and ensure fairer trading practices for everyone.
That'd be incredible.
Yeah.
Right. So financial markets are one potential application, but what other scenarios could solar revolutionize? I have a feeling you have more ideas up your sleeve.
Oh, I always have more ideas. How about something a little more intense? Imagine a military scenario where an AI is tasked with coordinating troop movements, managing logistics, and making strategic decisions in the heat of battle.
Well, hold on. Are we talking about AI generals now? That sounds like something straight out of a science fiction movie.
Maybe not as far-fetched as it seems. An AI powered by solar could potentially analyze battlefield data, predict enemy movements, and adapt its strategies in real time, giving its side a significant advantage.
I see where you're going with this.
Yep.
But again, the ethical implications are huge. Are we really comfortable handing over life or death decisions to machines, even if they are incredibly intelligent?
That's a question we need to grapple with as a society, and it's a question that's only going to become more pressing as AI continues to evolve. But these are the kinds of conversations we need to be having now so we can shape the future of AI in a way that aligns with our values.
You're absolutely right. These aren't just hypothetical thought experiments. They're glimpses into a future that's rapidly approaching.
Oh,
Okay, those were some mind-bending applications, but I have a feeling you saved the most radical novel notion for last. Am I right?
you know me too. Remember our earlier discussion about combining solar with curriculum learning?
Uh-huh.
Let's take that idea to its logical extreme.
Okay, I'm on the edge of my seat. Tell me more.
What if we could create an AI that starts with the reasoning abilities of a toddler, then gradually learns and develops just like a human child? We could expose it to increasingly complex information, challenge it with progressively harder problems, and essentially watch its reasoning abilities evolve over time.
So instead of trying to program intelligence from the top down, we'd be growing intelligence from the ground up, allowing the AI to learn and adapt on its own.
Exactly. And if we combine this approach with Solar's dynamic reasoning structures, we might end up with an AI that can think as flexibly and creatively as a human being, or perhaps even surpass human capabilities.
That's both exhilarating and a little unnerving. We'd be creating a whole new form of intelligence, something that could potentially reshape the world as we know it.
It's definitely a thought-provoking concept. We're talking about pushing the boundaries of what's currently possible and venturing into uncharted territory. But that's what makes AI research so fascinating. It's a constant exploration of the unknown, full of possibilities, challenges, and mind-blowing discoveries.
Well said. And on that note, I think it's time to wrap up this episode of TalkTensors. We've covered a lot of ground today, from the technical details of the solar paper to some truly mind-bending novel notions.
It's been a great discussion.
As always, and for any listeners who are inspired to explore these ideas further, we encourage you to check out the solar paper. We'll include a link in the show notes.
Definitely worth a read.
And if you come up with any groundbreaking novel notions of your own, be sure to share them with the world. Who knows? You might just spark the next revolution in AI. Thanks for joining us on TalkTensors, and we'll see you next time for another deep dive into the world of machine learning.
See you then.